Hey everybody and welcome. Today we're going to be talking about rational expressions. So your goal after watching this video will be able to understand what rational expressions are and also apply them to some context in terms of interpreting their domains, simplifying them, and just generally getting comfortable working with them. Looking at a bit of a different format today, I'm going to be using some book widgets for this. Hopefully basically the way that you're accessing this will be a little bit easier and a little bit cleaner to look at. So always open to feedback, but going to give this a shot to start off quarter three. So getting started here, our word today again is rational expression. And the definition of this is a ratio of two polynomial expressions. So again, a ratio of two polynomial expressions. And an example of this is, if you remember back to polynomials, something like a monomial, well, that would be like just a number, right? And then maybe you have a binomial on the bottom. So there's one polynomial on top, one polynomial on the bottom, and they come together to make a rational expression. Just as a side note here, our denominator can't equal 0. So as long as that's the case, we'll be in good shape. So for example, if we had an x value of x equals -2, x cannot equal -2 here because it will not be defined at that point. So just a side note, sometimes they're going to ask you, and one of the skills we're doing today is to identify when the function is not defined. And again, that's basically what they're asking for, is making sure that the denominator, or the bottom of the fraction, does not equal 0. All right, so some of the questions that you're going to be looking to submit and upload on book widgets here, are going to give a few examples of them. So the first one is just asking, are they or are they not rational expressions? Now remember, two polynomials in a ratio give us a rational expression. So if we're looking at something here, we have to make sure that they are actually polynomials. Well, on top, that's a trinomial, 3 terms, it's good. On the bottom, binomial, 2 terms, it's good. But you might run into something where it's not a polynomial. And I'd encourage you to look back in your notes for that video. But some of the conditions where we can't have square roots, we can't have something where in the actual expression itself, you can't have like an x on the bottom, for example. And just generally looking at no negative exponents, fractional exponents, things like that. So making sure, or being careful with our exponents. So if you see any of those conditions violated on either the top or the bottom, then you know that, again, that's the case, that it won't be a polynomial. Now, if you look here, the question might be asking is, well, Mr. R, there is an x on the denominator here. There is an x on the bottom. Well, that's okay, because it's actually, we view this entire thing as the polynomial. So if this on the bottom, so let's say, for instance, it was something else like, I don't know, 2 over, 4 plus 1 over x. Well, now this violates it because of the x on the bottom here. But it is allowed to be, generally speaking, on the bottom. It just can't be, again, violating that polynomial term when we individually analyze those polynomials one step at a time. So you're basically checking to see, is the top a polynomial? Is the bottom a polynomial? In that order. If the answer to those questions is yes, then you're good to move on. A second skill, asking us what's excluded from the domain, and that's just asking us, make sure that the denominator does not equal 0. So it's going to be your job to solve the denominator for 0. So in this case, you take the denominator and you set it equal to 0. Well, when you solve this, you're going to see that you get an answer of -1. So you're going to say x equals -1 is excluded from the domain. And for that second question, you're going to actually have to do the same thing. So you're going to take this, set that equal to 0, solve for your two x values, and then those will be the two things that are excluded from the domain. So again, setting it equal to 0 because the bottom can't be 0, so we're trying to identify those values on the bottom where it can't be. All right, and then our last subset of questions involves us doing some simplifying. So it asks you to simplify. It's basically your job to factor individually the top and the bottom one at a time. So if you look at both of these here, these are two things to factor. Well, if we look at our factoring of 4 and of 8, we have a 2 and a 2, and here we have 2 and 2, actually another 2. So they each have two 2's in common. There's only one x, so we can't take anything out. So it looks like 2 times 2 is 4 is what we can factor out. And what's left is just x for the first term, and then just a simple 2 for that second term. We're going to do the same thing on the bottom, so we have 10x and 20. So we have 5 times 2 here, and it looks like we have 5 times 2 times 2 here. Well, in this case, we actually both have a 5 and a 2 that you can take out. So that's going to be 5 times 2 is 10, an x for the first term, and a minus 2 for the second term. And the reason why we do this is if they have anything in common, you divide anything by itself, it equals 1. So if we take our term here, sorry that just canceled out on me. If you take, and did it again. Again, looking at the term here, this is the same thing. So if you divide x over x minus 2 divided by x minus 2, it cancels out to give you 1. So you're just left with 4 over 10. And again, we can further simplify that to 0.6 or 2 over 5. And that's going to be your simplified answer. We're not changing it. We're just rearranging things so that we can basically divide things by themselves and get 1. It's going to be your job to do the same thing for B, C, and D here. Again, totally factor the top, factor the bottom, and anything that's in common, we can simplify to be 1 if it's on the top and the bottom. All right, everybody. Well, hope this new format is helpful for us. As always, any questions, feel free to reach out, email, remind, message, any of those types of things. We are here to support. Thanks so much for tuning in, and I'll see you in class soon.